How does ODP impact HVAC refrigerants? Imagine a layer of Earth's atmosphere that shields us from the sun's harmful ultraviolet rays. This layer is called the ozone layer. Now, some chemicals used in air conditioning and refrigeration can harm this layer. That's where ozone depletion potential, or ODP, comes into play. ODP measures how much a refrigerant can damage the ozone layer. The higher the ODP, the more it contributes to ozone destruction. Refrigerants like chlorofluorocarbons and hydrochlorofluorocarbons have high ODP because they contain chlorine or bromine atoms. When these chemicals leak into the atmosphere, they break down ozone molecules. One chlorine atom can destroy tens of thousands of ozone molecules over time. This damage lets more ultraviolet radiation reach the Earth's surface, which can cause health problems like skin cancer and eye damage, and harm ecosystems. In the past, many HVAC systems used refrigerants such as R12 and R22, which are chlorofluorocarbons and hydrochlorofluorocarbons. These substances had high ODP values, which led to international efforts to phase them out. The Montreal Protocol, an agreement made in the 1980s, aimed to stop the use of these ozone-depleting chemicals. As a result, the industry shifted to refrigerants with zero or near zero ODP, like hydrofluorocarbons such as R for 10A and R for 50. For B, these newer refrigerants do not contain chlorine or bromine, so they don't harm the ozone layer. Switching to low-ODP refrigerants affects HVAC system design and maintenance. For example, replacing R22 with R for 10A requires adjustments because R for 10A operates at higher pressures. Engineers must ensure that system components can handle these different pressures and thermodynamic properties. This means checking the compressor, expansion valves, and piping to make sure everything works safely and efficiently. While ODP focuses on ozone layer damage, it is also important to consider global warming potential, or GWP. Many low-ODP refrigerants still have high GWP, which means they can contribute to climate change. That is why the industry is now working toward refrigerants that have both low ODP and low GWP. This helps reduce both ozone depletion and global warming. In practical terms, using refrigerants with low or zero ODP involves designing or retrofitting HVAC systems to handle these new chemicals. It also means implementing strict leak prevention, regular maintenance, and refrigerant recovery practices. These steps help minimize environmental impact and ensure compliance with regulations. Staying informed about phase-out schedules and new refrigerant options is essential for engineers and technicians. In summary, ODP influences the choice of refrigerants in HVAC systems by guiding the phase-out of substances that damage the ozone layer. This shift pushes the industry toward safer, more sustainable options. Mechanical engineers play a key role in selecting, installing, and maintaining systems that meet these environmental standards.